Okay, we're going to do what's called a collision analysis with our with the next couple of pages, and I created a new situation that's different from the ones that are in your packet to help you guys solve this, to give you an example of how to solve one of these things. And so first thing we're gonna do, we're gonna read, we read our scenario and we identify the things that have mass or velocity. And so we have a 100 kilogram hockey mascot, so there's a mass, right? 100 kilogram hockey mascot is launching 0.6 kilogram t-shirts from an air cannon into the stands. Okay. Well, the skater is skating towards the wall of the rink at 1.2 meters per second. Okay, and the shirt leaves the barrel with a muzzle velocity of 25 meters per second. And we need to fill in the table below, assuming there's no external forces. Well, so what we're going to do over here is we're going to identify the things that we have. So we have a skater, okay, and we have a t-shirt, and we have the total momentum of the both of them. All right, and so to fill this in, we need to figure out what the momentum of each thing is beforehand, and the momentum of each thing afterwards, and then this is going to be our changes in momentum. But before we even go there, we should be able to figure some things out. If there's no external forces, then what should we have down here for our total change in momentum? Well, no external forces means that there should be zero change in momentum, right? Which means that our total momentum before this one, these two, should be equal to each other. And it also means that this one plus this one should equal 0, that these two added together should be opposite to each other in order to equal 0. And that's if we have no external forces. So that's just a beginning idea here. And that's going to change, and that's also going to affect what we have in these boxes over here. So let's start our process. And the first thing we need to do to find our total momentum of everything beforehand, or to find our individual momentums, we're either going to find our total momentum of everything beforehand, or we find our individual momentums and we're going to add them together. And I think in this particular case, it might be easier if we find our total momentum of everything beforehand, because before the skater and the shirt system gets launched, they're traveling at a velocity equals to 1.2 meters per second. And they have a combined mass of, or total mass, is going to equal the 110 kilograms plus the 0.6 kilograms for the t-shirt, right? And so our total momentum, okay, is going to equal our 110.6 kilograms times our 1.2 meters per second. All right, so we're going to get our calculator here. All right, we'll bring that over and see if this may or may not show in the video, but I'm doing a 110.6 times 1.2 to give us a total momentum of 132.7 132.7. I'm just going to use the tenths place kilogram meters per second. But to find the individual ones, we have to multiply the individual masses by our initial velocity. And so we need to break these two up. And so we're also going to have to do 110 kilograms times 1.2 meters per second times 1.2 meters per second. And that's going to give us 132 kilogram meters per second. 132 kilogram meters per second. And then we also have the 0.6 kilograms times 1.2 meters per second. So this is momentum of skater, and this is momentum of the shirt. And that's going to equal 0.72 kilogram meters per second. So 0.72 kilogram meters per second. All right, so this is all what's happening before. Now afterwards, we have the shirt leaving the barrel with a muzzle velocity of 25 meters per second. Okay, so our P final for the shirt is going to equal 0.6 kilograms times 25 meters per second. Okay, and that's going to wind up being 9 kilogram, right? Am I doing that right? No, I'm not. That's not right. That should be 1.5 kilogram meters per second. So down here we're going to have 1.5 kilogram meters per second. Okay, and that means that if we take right, 25 times 0.6, 0, carry the 3. Oh, that's 15. 15 kilogram meters per second. So we need to change that over here. All right. But if our total momentum is the same at 132.7, okay, then that means our momentum afterwards, remember this stays the same, our momentum afterwards means kilogram meter per second, is that this is going to be our 132 minus however much this one increased. And so this one went from 0.72 to 15.0, and that is an increase, that is a positive change of 14.28 kilogram meters per second. And if this increases by 14.28 kilogram meters per second, this one has to decrease by 14.28 kilogram meters per second, because we know that our total momentum change is going to equal 0. And so if we have a decrease in this much momentum, that means this value is going to be this 132 minus the 14 that it lost, which will wind up being 116.7 nope, because I can't do this in my head. It will be 117.72. Yep, that makes sense. 0.72 kilogram meters per second. Okay, and that's how we do our analysis. Is that our momentum before plus our final momentum minus our initial momentum is going to equal the change, and our final momentum minus our initial momentum equals the change. We know that these two added together. All right, so let's do this analysis here. That these two added together are going to equal this, and that these two added together are going to equal this. These two added together equal that. Okay, our delta P always equals P final minus P initial, and so it's our final, it's this one minus this one to give us our delta P. Okay, and so this column is this column gives us our third column. And so we're looking to fill these out, and then we finish the question. And so there's one more question to this, and that would be what would be the final velocity so what is of the skater? All right. Well, to do that, we find out that our we take our after momentum, and we're going to divide that by 110. And we're going to find out that it's a little bit less than the 1.2. It doesn't really slow down a whole lot because of the mass. But we would take our 117.72 kilogram meters per second is going to equal our 110 kilograms of the skater times his final velocity. So we divide by 110. And we wind up with 117.72 divided by 110, and that winds up being what was that? Oh yeah, 1 equals 1.08, right? No, 1.07. That winds up being 1.07 meters per second with a change in velocity of like 0.12, right? Because it was traveling 1.2. Yeah, so 0.15. No, 0.13. That's what it is. Okay, so he's going 0.13 meters per second slower. And why is that? Because the shirt isn't real heavy, and so it doesn't have a whole lot of mass. But a skating, the guy in full costume skating is going to be pretty heavy. Okay. So, but that's our analysis, and that's how we find these final answers, is by finishing that analysis. Okay, so that's it. That's how you do these kinds of problems, and you guys should take notes on this and show me, and we'll see you next time.